this equation. Or you can say the two lines are parallel or almost parallel because this interaction, this is beta 3 or B3 is practically zero. Okay, if you look at the notes, you see I ran this regression, exactly the same thing here. This is that I just put it in the notes here. And this is the regression equation. You see you have the systolic blood pressure, estimate of systolic blood pressure, intercept. This is the slope for age. And then the coefficient for sex. And then INT here is interaction. And in the, I call it age sex, but INT interaction here. So which is age and sex here, just I put that. So the age times sex. Now, if I use that systolic blood pressure as a y, and then x1 is age, and x2 is sex, which is a dummy variable, 1 if it's a male, 0 if it's female, and I come up with this equation. You see, this is the equation. This is an estimate of single equation model. We estimated value for each of these betas, beta 0, beta 1, beta 2, beta 3. Now, based on that, I come up with the two equations, one for male and one for female. As long as I insert the value of x2, which is 0, 1, and I can achieve that. Here I show you that. Here is, you see, if x2 equals 0, which means referring to female, this is the equation. Every time I see x2, I just plug a 0 there, 0, 0. So again, this part, this 129061 times 0, and this part, well, these two are will go away because they have a 0 component, so these are become 0. So again, you see you have that equation. That's the estimated equation for female. And then if I put 1 for x2, remember x2 is dummy variable. So here we have the constant. x1 is already age, is fine. You see I put the 1 here and then 1 hit there. So this becomes 12.961. So I add this 97 and this 12 together, I get 110. And then 94.9 and this 0.012 together, I get 0.961. And these are exactly the same equation we found in the beginning of the lecture by SPSS twice. I was able to generate these two equations by just using a dummy variable, using gender as a dummy variable, and this two equation is a result of these two equations. Now, go back to the SPSS. I'm going to talk a little bit about the dummy variable and the characteristic of dummy variable. Here, if you look at the output in that SPSS, you see this is the multiple regression. This 12.96 actually always the standardized coefficient of the dummy variable, that unstandardized coefficient of dummy variable, is a difference in outcome variable between the two groups. The outcome variable here in this example is systolic blood pressure. This is a difference in systolic blood pressure between male and female. When the age is controlled, when the age and this interaction is controlled for, all right? So we have that number. So this is the, again, difference in systolic blood pressure between male and female when we control for age. Now, I can give you also, look at the systolic blood pressure. We already have the systolic blood pressure in our data set. Okay, go back to the data set. We have the systolic blood pressure. We have this group, male and female. We can calculate what is the mean of systolic blood pressure for male, what is the mean of systolic blood pressure for female, and is there a difference between the two means? You see, we have that systolic blood pressure, and we have this category 0, 1. So this is an example of t-test, it's a two-sample t-test. So I run that. I click on Analyze, Compare Means, Independent Sample t-test. I move the systolic blood pressure as a variable, as a test variable. Sex goes to grouping variable. So you have two question marks. I have to take care of those two question marks. So I click on Define. I know I have one value 0, one value 1. This is the dummy variable x2, or we call it sex here. So I click continue. You see I have 0, 1 there, and I click OK. And that's give us a SPSS output. As you see here, you see the mean systolic blood pressure for female is 139, almost 140. And then for male is 155. So there is a 15-point difference between the two, which is, you can see here the difference is 15. This is exact difference, 15.288. Now, why over there, as I said, difference? Why is 12 here? Here is 15. The reason is 12 here because that number is adjusted for age. That's the idea in multiple regression. I mentioned that many times. In a multiple regression, we only concentrate on the marginal contribution of each variable, not absolute contribution. Absolute contribution of variable only is possible if there is zero correlation between this variable, which is very rare. In the real world, never happens.